Okay, good morning everyone. We are now live and live online as well. Welcome to our breakfast seminar. Today we'll be talking about net zero carbon, obviously, and specifically taking steps towards a net zero carbon data center. There are some housekeeping things I need to go through first. So there are no fire alarm tests planned during the course of the presentation. If the alarms do go off, we do need to exit the building. So we'll make our way out through those doors there, and the assembly point is over there. And then there's also a Slido in the corner there, so don't worry about scanning it now if you haven't done already. We will have a couple of questions as we go through, so watch out for those. So yeah, welcome to the people in the room that have joined us in our London office, and welcome to those of you online, wherever you are. Thanks for taking the time to be with us today. I'll move on. So there's 5 of us presenting for you today. Myself, I'm a partner in the team. Junji Zhu, Principal Mechanical Engineer. We have Mariana next, Principal Mechanical Engineer also. Tim Stidwill, Structural Partner from the Birmingham office, and Damien Dungworth from our Newcastle office, Civil Engineer. So the agenda for today, I'll start off with an introduction, set the scene a little bit, talk about policy, how we're getting on at the moment. I'll pass to the rest of the team to go through net zero carbon and Cundall's approach to that. Then we'll have a little bit of a dive into operational carbon and embodied carbon, some examples of things that we may be able to do differently there from a design point of view. And then we'll wrap with a short conclusion and some questions and answers. So questions, obviously, from the room. We'll have a microphone. Xander at the back there has the mic ready. So if you want to ask a question at the end, please put your hand up and we'll go to you for the questions. Xander will give you the mic. Please do speak into that mic so that the online audience can hear. And then Alex Stewart, to my left there, is going to be monitoring online questions. So if you're online and you have a question, please put it in the Q&A section of the Teams app. Hopefully that's all working, and Alec will pick out questions from there, and then he will ask them on your behalf in the room. So that said, let's move on. So introduction, why are we all here? Well, we're talking about embodied carbon in data centers, but obviously the planet has a climate change catastrophe on it. So there is no planet B. That's the message. I think it speaks for itself. So what policies? Let's have a little bit of a look at the policies. What policies are driving this change and helping us to achieve that? Well, the overarching global agreement really is the Paris Agreement. That's a UN agreement which is signed by 196 member parties. And it's really seeking to limit the global warming to 2 degrees C below by the end of the century, and ideally 1.5 degrees C. So that's what we're trying to do from the Paris Agreement. And then there's a number of other policies globally and initiatives and legislation that come from the back of that. Thinking about Europe, we've got the European Green Deal. That's really Europe's response to the Paris Agreement. And it's looking to set a path to green transition and be the first climate neutral continent on the planet by 2050. So that's the aspiration of the Green Deal. And it encompasses everything from circular economy, initiatives, energy, environment, finance, and those sorts of things. Focusing a little bit more on Europe, this is a moving feast. The policies are growing and changing almost day by day. But all of the member countries in the EU have set nationally determined contributions, NDCs, so they're bringing up legislation and initiatives to achieve those NDCs, and it's all tied into that Paris Agreement that I was talking about before. So there's a multitude of policies, too many to mention. And one of the ones we should highlight is UK Green Building Council. Their net zero carbon building standard is due this year. We've been part of that negotiation on the various documents they're working on across all of the sectors. And it's first question time. Please, if you've got your smartphones on you, get them out, scan that QR code. If you're online, you can just scan it on your photo app on your phone. It will take you to the app. I'll give you a second to do it. Yeah, come on, Tom, get it out. So what are we trying? The first question is about where do we need to be? So in line with that Paris Agreement and trying to limit our global warming to 1.5 degrees, we need to be 45% under the greenhouse gas emissions by 2030 compared to 2010 levels. So that's 45% under compared to 2010 levels. The question is, are we on track? Hopefully that's working. So that should now go live for you. You can say yes or no. And let's see, we should have some live feedback. I thought that might be the answer. Who's going to be brave and say yes? Okay, yeah, overwhelming no. And sadly, Yeah, you're all right. We're nowhere near that. We're nowhere near on track. We are on track to be 9% above. So that's not 45% under, that's 9% above. It's a disaster. So we're all falling behind. COP28 happened, all of the countries are getting together again. We need to make a drastic improvement, and everyone is going away and seeing what they do to improve their NDCs. We need to make drastic changes quicker. So sad picture, I'm afraid, to report there. So we do have a problem. COP28 as well, there was the global stocktake, which was all of the countries coming together and putting in their information and data on carbon, and that's really where we've got to in terms of these predictions. The chart on the right is a pretty depressing one. The blue curve at the top there, if you like, is where current policies will get us to. And the predictions are 2.5 to 2.9 degrees C above those temperatures. We can't imagine what that will do to the planet. So that's where we're heading. This is where we need to get to. The green line is where we need to get to. We need speed up of these transitions. We need improved financial, technological support, particularly to vulnerable nations. And we need to do it now and quicker. What does it look like in terms of our sector and the emissions of our sector? So if we look at global energy consumption and greenhouse gas emissions, we have on the left there electricity consumption estimated as various sources. This is from the International Energy Agency. It's about 1.1 to 1.3% of global energy electrical consumption. If you include cryptocurrency mining, that goes up to 1.7. They're in our data centers, so we have to lump them in. So they're part of that. In terms of the greenhouse gas emissions as a result, it's around 0.6% of the total greenhouse gas emissions. We shouldn't be thinking that's a good small figure because it's still a huge amount of megatons of CO2 and we're responsible for that. So that's not good. And then the current targets now that people are talking about is we need to emit half our emissions by 2030. So that's the challenge ahead of us. It's not easy. That's why we've gathered everyone together. We want to talk about it more. There's obviously lots happening, but these targets are not easy to achieve. I'll hand over now to Mariana, who will talk about our approach at Cundall.
Thank you, Peter. Good morning, everyone. Thank you for joining us. So, in this context, what is really net zero carbon? So, in Cundall, we're approaching net zero carbon as achieving a balance between our greenhouse gas emissions and the greenhouse gases that are being removed or offset from the atmosphere. What is key in our approach, though, is that we minimize our emissions first, as much as possible, through the right site selection, design decision, or equipment selection. And after we've done our best to minimize our emissions, only then we consider carbon removal or offset initiatives. This approach is aligned with the World Green Building Council approach, which are really calling for a complete decarbonization of the built environment. So we're also calling the industry to adopt a whole life carbon approach to net zero carbon balance and account for both operational and embodied carbon emissions and all the scope 1 to 3 emissions. Mention operational carbon, mention embodied carbon. Operational carbon is really what we're most familiar with. This is all about the emissions related from energy consumption on site and all the activities that are going on in the building. For the data center, of course, this is our IT racks, mechanical and electrical infrastructure energy consumption. Embodied carbon, on the other hand, is a different beast. It goes beyond the boundary of our data center, and it accounts for the entire supply chain. So this means we are considering here emissions related to extraction and processing of raw materials, transportation of the piece of plant to site, and the construction process itself. Another way of, let's say, slicing and dicing carbon emissions that is being used for carbon reporting purposes is the use of scope 1, 2, and 3 emissions terminology. What is scope 1? Scope 1 is our direct emissions, are the emissions that we as the organization are responsible for, and they are within our control. For a data center, that would mean emissions from fuel consumption in our generators, and refrigerant leakage, for example, from chilled water systems, and their subsequent decomposition to chemicals and the so-called PFAS as well, that is becoming more and more of a concern. Scope 2 is our indirect energy emissions. So these are the emissions that are associated with the utilities we are purchasing. So for a data center, that would mostly be our electricity consumption. Scope 3 is everything else. It's all the indirect emissions and accounts for the entire supply chain, including our employee commuting to the site, and waste disposal. So in Cundall, we are proposing a 7-step approach to get us towards a net zero carbon status. We start with a passive design optimization, which really means we try to reduce demand at first, even at due diligence stage, at site selection stage. Then we move to reducing our operational carbon through the right equipment selection, infrastructure design. We try to eliminate fossil fuels, up for debate, and we're looking into providing renewable energy from local sources as much as possible. We want to limit our upfront embodied carbon through the right material selection, equipment selection, and we want to make whole life carbon analysis part of the entire project life. It's not just the designer problem or just the contractor problem, it's the entire life of the project. Finally, we are calling industry to disclose the data. Same way that data center operators are disclosing PUE and WE values, we invite the industry to start disclose their emissions as well. During the presentation today, my colleagues will talk you through some of the steps in more detail. But before we do so, I have another question for you, so you can use your mobile phone again. So from your experience in the industry, really, we want to understand which one do you think is the biggest challenge to tackle? Is it operational or embodied carbon? And there's no right and wrong. We just try to understand from your experience what your feeling is. Yeah? Okay. Okay, the room. 70% embodied carbon, 30% operational carbon. I think, yeah, this is really the split. So I think this is kind of what we were expecting as well, that we think that tackling embodied carbon is a bigger challenge than tackling operational carbon. And on that note, I'll pass now to my colleague, Junji, who will talk you through the operational carbon aspects of a data center.
Thank you, Mariana. Good morning, everyone. In the next few slides, I'm going to talk you through the operational carbon for a data center. To start, let's have a look at the site selection. So the site selection is the first step for a data center design. It's very important, and it will have a direct impact on the future operation carbon emission. To moving forward to a net zero carbon data center, a lot of considerations need to be taken into account at the site selection stage. Like, what's the grid intensity? What's the climate condition? Is it hot? Is it cold? Can we use longer period of free cooling? What about the waste heat recovery? Is there any connectivity available? Is there any infrastructure ready for it? There might be no perfect site can tick all the boxes, but the point we want to make is moving towards net zero carbon during the site selection stage. Among all the decision-making criteria, we need to put the factors have an impact on carbon emission at the very beginning. So, optimize MEP system efficiency. The mechanical cooling system takes a lot of energy to keep the data hall up and running in the well-controlled built environment. And the industry is well aware of it, and actually, we are working quite well in the past 15 to 20 years' time, try to push down the operational carbon of the data center cooling system. With the recent development of the AI and machine learning, we have noticed the power density of the IT racks in the data hall has been increased significantly over the past few years. And the trend for mechanical cooling solution has been moved from a direct air system towards a chill water-based system. And on our recent projects, we have seen clients start to adopt the liquid cooling on their recent data centers, which creates a lot of design challenges, but also creates opportunities for further improve the system efficiency, because the technical water loop for liquid cooling can operate at a much higher temperature compared to the traditional chill water system. It's not all about mechanical system. We can also look into the electrical infrastructure as well. So there are considerations we can take to minimize the electrical power distribution loss. What should be the voltage for power distribution? What improvement we can have at the transformers? What UPS system can do the improvement? with all these small increments, we can make a significant impact on the overall MEP system efficiency. Now we all know that operation of data center will consume a lot of electricity. So how to power our data center using renewable power source becoming crucial for the pathway to net zero carbon. And renewable energy certificate and power purchase agreement is quite popular, currently adopted by a lot of data center owners and operators. But both of these approaches have some limitations. For example, the IECs will allow you offset your data center operational carbon at one location by investment in a renewable infrastructure on a different location. The PPA is a little bit better compared to the RCE in our opinion, because long-term agreement will be made between the data center customer and the renewable energy supplier. However, due to the limitation of some of the renewable generation technologies, such as the solar power, the wind power, which will rely on the weather condition to make it work, there will be occasions when the grid needs some fossil fuels to support the demand. A more advanced and recent approach is the time-matched renewable electricity, which means it will matching the renewable generation and the customer's consumption by a 24/7 hourly basis. And that renewable energy typically will be purchased locally to the market as well. It is a much step forward compared to the PPA. And we are glad to see a lot of data center operator and owners has committed to that approach. And very ambitious target has been set out as well to achieve 100% time-matched renewable electricity in the near future. So we all know the demand of data center will keep high for a period of time, and the grid capacity will be limited. So what else can we do? Can we think out of the box? We might need a different session to have more debate and discussion, but how about we build our own renewable generation? How about SMRs? So move on to the waste heat recovery, which means reclaim the waste heat from the data hall and export it to the utility company. From there, the utility company will distribute the heat further to the local district heating or cooling network. Look at the recent European Union policy. Data center over 1 megawatt IT capacity will need to have waste heat recovery. And the UK government also tried to encourage the waste heat recovery from a data center by invest more funding in this area. In terms of the technology, actually it's not something new. For example, shown on this slide, we have delivered several data center projects in Denmark with waste heat recovery infrastructure, providing heating and hot water for thousands of households locally in the community. But moving towards net zero carbon, how we can make it normal, how we can make it feasible. If there's no infrastructure ready in day one, what we need to do? So we think design considerations should be given in the day one design stage. We need to have sufficient space allowance, not just a box. We need to consider all the possible plant required. And more importantly, we need to make sure in the future, when the utility is available, we can connect into the district heating network without the impact of the live data center operation. Backup power. So traditionally, it is quite common to provide a diesel backup generator for a data center as a backup power supply solution. But let's challenge the status quo. The utility supply is actually quite resilient. Sometimes we can achieve 5 nines availability. Generator only running when tested, which sounds great in terms of operational carbon, but the fact is most of the energy generated during the test will be thrown away in the air through load bank. And does all the load in the data center need a backup generation? If we do end up with a backup generation on site, using HVO fuels can lower the net emission by 90% compared to the traditional diesel generator. And we can also make use of the waste heat from the data hall for the generator engine block jacket heating. And any other solutions in the horizon? Have we considered fuel cells? Have we considered energy storage? What about gas turbine with carbon capture? So far, we have been quite focused on carbon emission, but what about water? So evaporative cooling system was quite popular in the data center world. It can improve the efficiency of the system, reduce the energy consumption for mechanical cooling, but consumes a lot of water. And water is not just a medium for cooling, it's also a very, very valuable natural resources. And as shown on this map, it's a drought map of the world. And as we can see, there's a lot of red areas which suggest very high drought risk. And additionally, to bring the water to the site actually will have a carbon footprint, and example given here for the UK water industry carbon factor. So when we consider the way towards net zero carbon, we should take consideration of the water consumption, and we think we should use a waterless system at the water stressful area. It's not all about the energy consumption, it's also about a wider picture of the sustainable environment. Finally, I would have a discussion on the PUEs, which probably is one of the most important metrics widely used in this industry to define the energy efficiency of a data center operation. I believe everyone here today and everyone online is very familiar with what is PUE, so I won't necessarily go through the detail of the equation on the left. But moving towards net zero carbon, we need a benchmark. What is a good looks like? So Condor has been involved in the net zero carbon building standard working group, and specifically our critical system involved in the CS sector working group. So internally, we also do a data collection on all of our projects to try to collect the PUE information. We have included all the projects we have been designed, delivered, constructed, and also including a lot of feasibility studies we have done on data centers globally in different locations, different climate conditions, different cooling system. And the table on the right gives a high-level summary of what we think as a best practice we should target for a good practice or a very energy-efficient data center. These numbers will be keep changed and updated with more projects involved, with the improvement on the system efficiency. But we think that table is a good step, first step, moving us towards the net zero carbon journey. So now I'm going to hand over to my colleague Tim to talk to you more about the embodied carbon. Thank you.
Great, thank you very much, and good morning, everybody. So when we look at the overall carbon footprint of a development, we look at the summation of the embodied carbon and the operational carbon. As we've already heard, as time is going on, the impact from operational carbon is reducing with the decarbonisation of the grid and more efficient systems. So the impact from the embodied carbon on a development is becoming more and more relevant. So we really need to drive down those embodied carbon values on projects. Let's look at an example high-rise commercial building. So this is the Leadenhall building or the cheese grater. And what we can see here is that the relative proportions of embodied carbon show that the structure here is the most impactful part of it. So typically you'll find between 50 and 80% of the upfront embodied carbon will be attributable to the structure for typical buildings. But it's slightly different for data centres. This is a project that we've recently submitted for planning where we've produced a whole life carbon assessment by the Cundall team. And this shows there's a stronger balance between the structure and the building services and the below ground services. So around about 43% for each. So we can see there's an increased influence from the building services and below ground services and infrastructure on the overall embodied carbon footprint of data centre developments. So these are three areas that we really focus hard on in terms of our embodied carbon reductions. So just thinking about the structure and what we can do in terms of reducing embodied carbon, first of all, the Institution of Structural Engineers has produced a carbon rating system which it calls SCORES, so that's the structural carbon rating system. And that's got a grading system from A++, which is virtually no embodied carbon in the development, to G, which is a very high embodied carbon intensity. So we use this rating scale for all of our projects, all of our structures, to see where we rank. And it's really important over time that we're reducing embodied carbon impact and we're setting harder and harder targets every year. And there's quite a lot of work going on in the industry at the moment, in the construction industry, to develop databases to work out what does good look like in relation to embodied carbon. So again, the Institution of Structural Engineers have developed some data relating to residential sector, commercial sector, education sector, as to what does good look like in terms of embodied carbon. And you'll see the box that I've highlighted, the scores ratings around about B to C, which is around about 150 kilograms of carbon dioxide equivalent per square metre GIA, up to 250. However, there isn't an awful lot of data out there for data centres at the moment. We don't really have benchmarks. So what we've been doing within Cundall is assessing the embodied carbon of all of the structures that we've designed in the data centre sector. And we've categorised it in a few different areas. So we've looked at single-storey, two-storey, multi-storey. We've had a look to see whether or not there's a relationship between the embodied carbon in each development and the megawatt of IT capacity, but also looked at it in terms of the embodied carbon intensity per square metre of GIA. In terms of the structures, we haven't really seen much of a correlation between the embodied carbon and the IT capacity, but what we have found is there's a strong correlation with the increased number of stories that you add onto a building will increase the embodied carbon intensity, which makes sense because data halls have quite a heavy equipment. They tend to have long-span structures, so we have to put some heavy structures in. So you expect that kind of increase in intensity going as you go up the building. So what we've looked at is an overall average, and we've developed a recommendation which we're using in-house, which is to limit our upfront embodied carbon to no more than 450 kilograms of CO2 equivalent per square metre for data centre structures. And if we find that with our developments that we're going over those limits, then we really question that and work out ways to reduce embodied carbon. If we're under that, we kind of share that knowledge and work out where we've got some exemplar working to make sure that we can get improvements going forward. And we're also looking at year-on-year improvements to those. Another area that we're working on with the structures is improvements from a baseline. So this is where we take a completed building, do an embodied carbon assessment on it, and see where we can improve it with our new designs. And what we've done is we've built an in-house tool within Revit, which will do a carbon assessment with a click of a button to work out the scores rating of these structures. So it's a very quick process for us to do this. In this example, we had a building that had a G rating, which is quite high in terms of the scoring system. And the building we designed, we managed to move it to a C rating, which had a 70% reduction in the overall embodied carbon. And we did that through a number of steps. So the first part was site selection. We've been talking about site selection already. The reference project had very poor ground conditions. So all the foundations had to be piled. We had to have a suspended ground slab. With the project we were designing, it had much better ground conditions, so we could use pads instead of piles, and we could have a ground-bearing slab. So we got a really good reduction there of embodied carbon through that the site selection. The second part of it was material selection. So looking at concrete in particular, can we use cement replacements to reduce embodied carbon? And can we also look at using lower carbon steels? So this is electric arc furnace steel, which uses a much higher percentage of recycled content and uses a lower energy source. So we can get some really good reductions with the way that we select materials. And then finally, looking at design, can we get design improvements to reduce embodied carbon? So refining the design, improving the design. With this particular example, we added some columns towards the edge of the data hall, which managed to reduce the span of the structure quite a lot, and that made quite a big difference. So overall, we managed to achieve a 70% reduction in embodied carbon. So a great story. So I'll hand over to Damien to talk about civil engineering aspects.
Hi, so yeah, I'm going to run through the external infrastructure embodied carbon and look at it from the approach of a hierarchy of opportunities that we have. So we have, what we're really going to focus on at the top there is removing things. There's not much we can do other than, that's probably the highest thing that we can do is actually take things out, challenge what we build, and then go on and look at reducing things, building less of what we actually need. Of course, we need stuff, but we can build less of it. And then we'll look finally at the minimizing carbon in the residual things that we make, the products that we use. Can we use lower embodied carbon in those? So I've got 3 examples, one for each. We'll look at the opportunity they have to save the carbon, some of the added benefits and some of the constraints that we have there. So the first example is, I'll go on to the baseline first, the embodied carbon in a data center. We've done some calculations on the embodied carbon. of the external works infrastructure. So that's the below ground services, the drainage, the roads, tanks for drainage, earthworks. And we're at about 41% for concrete, so that's the biggest component of the underground infrastructure. So that's what we're focusing on in a lot of the examples. But you can see some other big elements there. You've got 18% in earthworks, that's moving material around the site to create the plateaus for the data centers. We've got 17% in below ground ductwork, another big component, and the ductwork can include chambers, covers to the chambers, all of the components associated with it. So the first example is removing things, and we're looking at below ground drainage. And the opportunity that we've got here is sustainable urban drainage systems. They're going to replace a lot of the traditional components of underground infrastructure, where we might have underground concrete pipelines, manhole chambers, attenuation tanks, drainage channels at surface level. It's replacing some of those with more nature-based solutions. Swales, removing curbs from roads so water runs directly off into the swales, creating basins and ponds. Now, it's not to say that we don't do that on the data centers. We typically do. We do some of it, but I think we can go further and implement more of it on more of the data centers. Some of the added benefits with the SUD scheme are reduced flood risk, reduced pollution as well. We get water treatment from the nature-based solutions of SUDs. Increased biodiversity, again, that's becoming more of a planning issue where we've got to see increased biodiversity on the site, so it gives us an opportunity through these swales and basins to introduce that to a data center campus site. Improved well-being as well, finally, you know, that's another good one, is that the nicer environments to be around on a development. The main constraint, I would say, is the size of the site, and that comes back to site selection. Some of these do take up a lot of space. A swale takes up probably a 4 or 5 meter strip. And when we're very congested with underground utilities, it's not always a good option. We don't really want to be running swales on top of electrical duct banks or fiber duct banks or anything like that. So it's really trying to think about the size of the site and make sure that there is space for the introduction of these features going right back to the site selection stage. Another good example is duct and draw pits. And this one's really a reduction here that we're trying to think about. And it's really just trying to chip away at everything. It's breaking things down into the individual components and trying to reduce everything by a small percentage. Because when you bring it all back together again, cumulatively, you get some quite significant changes. So first there, we could reduce duct numbers and size of ducts, you know, challenge the redundancy. Now, of course, we can't eliminate duct banks, but, you know, maybe if we've got a duct bank of 12, there might be 2 redundant ducts in there. Do we really need them? Can we take them out? That's a relatively significant saving. Reducing concrete surround, as you saw on the pie chart there, concrete was 41% of the underground infrastructure. If we can eliminate the concrete surround, that's great. You know, huge savings. Why is it there in the first place? Of course, there are some technical reasons. You know, there's, you know, for the cables, for the heat dissipation, things like that. So, if, you know, there might be reasons why we need the concrete surround, but I think there are a lot of instances where it's in there really as a protection measure. So that comes back to the attitude of risk. You know, do we really need concrete surrounded duct banks for the risk of an excavator damaging one in a data center campus? Is it likely? Probably not, given the restrictions and the limitations that we have. Some of the added benefits there, better accessibility. If we went to things like surface channels, direct bury cables, you could argue that actually we get better accessibility to these for repairs and for maintenance, reduce risk to water on surface channels. I'm sure if you've been involved in data center campuses, you'll have experienced water in underground infrastructure. So, you know, there might be an opportunity there to reduce the carbon, but also get added benefits. Some of the constraints that lead us down these design decisions are standard design details. Often we have tight programs. We have a standard design, a standard-based design, standard duct templates, and that's what goes in. But, you know, if there's more time to negotiate these and rationalize them, then there's real opportunities to reduce the carbon. And then again, finally on that one, it's the attitude to risk again. It's, look, is there really a risk of a duct bank being struck by an excavator in a controlled environment of a data center campus? So we can challenge that as well. The final example here is it's a combination of all. It's removing things, it's reducing things, and minimizing things. We've looked at this in the context of a road and looked at all of the options that we can do to reduce the carbon in a data center road. So we could start with things like removing things. We could remove curbs and replace them with recycled plastic options. We could reduce road widths. Again, often we're faced with a standard design that might say we want a 7-meter wide road. But is that really necessary around a data center campus? You know, could it be one way? Could we reduce it down to 5.5 meters, even less, as a single way? So, you know, we can reduce the amount of pavement. Changing materials, you know, hot rolled asphalt, typically that has high embodied carbon, but there are alternatives. There are warm mix asphalts, foam mix, polymer modified asphalts. So again, we can substitute some of the materials with lower embodied carbon options. Recycled aggregates as well. Again, rather than naturally quarried aggregates, we can use a lot of recycled materials under road bases. The added benefits, again, from this is, you know, we can then start to create some space for the sustainable drainage if we can narrow the roads down. We use reduced materials to site, reduced transport loads, reduced environmental impact on the local neighborhoods, less asphalt, less urban heat. That can be important in cities with lots of urban heat gain. Constraints, again, I think it's standard design, which I mentioned at the beginning there. You know, we're given a basis of design that might say roads are 7 meters. So it's trying to challenge that. It's trying to have the time in the design programs to challenge that and agree alternatives and reductions. So just as a summary on this one, it's kind of looking at the compound improvements of that roads example, where we're removing things, we're reducing things, and then we're lowering the embodied carbon in the residual bits that we build. So that's an example of the road. If you look on the left, you've got 329 kilograms CO2 equivalent per meter of road, but we can get that down through narrowing the road, reducing the embodied carbon in some of the components to as little as 184 kilograms of CO2 equivalent per meter. And that's a 44% saving. So although the roads might only be 7 or 8% of the external infrastructure carbon, you're still making a considerable saving. That's 3% in the roads alone. And if we do similar on the duct and similar on the drainage, they all come together to make quite a considerable saving in the external works embodied carbon. So just to finish on a few key considerations there, I think one of them is considering the carbon from the site selection stage. You know, the site suitability. Is it in a floodplain? Does the levels need raised? Do we need to import lots of material? It's trying to get to a position where we can really manage the carbon in the development to low levels. Program for design and construction. I think inevitably the more time we have in design collectively, I think the more time we have to value engineer things, not only financially, but for carbon as well, to try and reduce carbon out of the design, to challenge the status quo, do things differently. Construction, again, it could be attitude to risk as well. If we build in a bit more contingency during construction, maybe we can do different things in construction to do with earthworks, for example, where we might just use reused material on site as opposed to taking it off site. And then finally, attitude to risk. Let's not over-design. Let's make sure that we're challenging everything that's there. And let's not, you know, put concrete around duct banks for something that, yes, it's a risk, but the likelihood is negligible. So, yeah, I think that was it for the external infrastructure. And I think we'll move on to the mechanical.
Hello again. So, MEP systems. So as Tim mentioned earlier, the contribution of MEP systems to the upfront embodied carbon of data centers is significant, and is actually significantly higher than the contribution in a normal commercial building. Guess what? The elephant in the room. Generators, switchboard, fan walls, chillers, kilometers of pipework, kilometers of cables, and of course, our IT racks, the reason we're building a data center. Now, it's true that getting access to detailed and accurate embodied carbon data for MEP systems is a challenge, and it's not a challenge for the data center sector only, but for all industries. This shouldn't really stop us, as there is ongoing research from vendors, industry bodies, consultants, to actually enhance our understanding on embodied carbon. In Cundall, we've been developing a database with MEP plant and materials embodied carbon, and also building in-house Revit tools, as Tim mentioned, to be able to inform our design decision and advise our clients on how they can get closer to a net zero carbon data center. Some examples of how we can use the database is by doing pipework material selection. So here we have an example for the 20 megawatt data center, and by looking at just the material of the pipework, going for HDPE pipework will only have 30% of the emissions of a steel schedule 40 pipework. And this is on the basis of exactly the same pipework diameter and the same system distribution. Of course, the actual numbers will vary depending on the amount of recycling in steel and where it's being produced, but you can get the picture. LV cable distribution strategy, again, another example. For the same notional 20 megawatt data center, if we choose to go with an above ground distribution of LV cables, we are already having only 80% of the imported carbon of distributing exactly the same amount of cables below ground. MEP plant. So this is tricky. So it's a challenge because MEP systems are comprised of many different components and different materials. So we understand that producing APDs or PPs is a challenge for the vendors. It's time consuming, and sometimes the information is not even there. Some vendors are doing better than others, they're more active in producing APDs, but it's a fact that there is limited data available in the industry. However, wouldn't it be nice to have, along with the energy efficiency of your chiller or the cost efficiency of a chiller, the embodied carbon efficiency of the chiller, and actually make this another KPI, another decision factor when you actually selecting a piece of kit? We know that it's early in the journey. We know that there will be uncertainties in data collection, potentially there will be some errors, but we really call the entire supply chain to embrace this approach and start getting the data there. Now, putting all the pieces of the puzzle together and understand what is the contribution of embodied carbon and operational carbon in a data center building. We're going to look at a case study. We've picked a 70 megawatt multi-story building in London. We've accounted for the carbon grid intensity of the UK to date and applied a year-on-year reduction over the 20-year lifetime of the building. I want to note here that for the purpose of this example, we haven't accounted for any plant replacement over 20-year building lifetime. So we start with a scenario where this data center consumes electricity from the grid. The orange part on the pie chart is the operational carbon contribution to the total, and blue is the embodied carbon contribution to the total. So at the end of year one, operational carbon and embodied carbon will be like 50-50, contributing to the total emissions. As we move to end of year 5, the pie will get bigger, and we see that the operational carbon is now contributing up to 80% to the total emissions of the data center. Moving to year 20, the contribution becomes 90% of the total, and the pie is getting bigger again. Now, we all know that data center owners or operators do purchase renewable energy. So if we take our pie at the end of the year 20 of the lifetime of the building with power only from the grid and start looking at scenarios where the operator selects to buy 80% of their power from renewable sources. In these examples, suddenly the 10% contribution of the embodied carbon to the total becomes 40%. And if the same operator opts to go for 95% renewable in their building, the embodied carbon contribution becomes 70% to the total. The picture completely changes. What this example really illustrates is not about the exact numbers, it's about showing that as we focus more on improving our operational carbon, and rightly so, we want to reduce our PUE, we want to use renewable energy, the contribution of embodied carbon will become dominant. And to date, in the industry, there is little focus, little understanding on what embodied carbon is. So if we're really going to go back to the vision of the World Green Building Council and look at the decarbonized built environment, it's important to act fast, start understanding our embodied carbon, quantifying it, and make it another KPI, like our PUEs and WUEs, which is something that's broadly used in our industry. And on that note, I'll pass on to Peter to get us to the conclusions.
Thank you, Mariana. But yeah, we'll just wrap up with a short conclusion for you, and then we'll take some questions and answers. I think we're doing, excuse me, we're doing very well on time. So yeah, not really a technical summary from me at the end here, because you can remember what you've just seen, I'm sure, in the last 30 minutes. It's more of an emotive conclusion and a plea, really. So what do we need to do? I think we can all agree the carbon picture is horrifying. We need to do more. So how can we change the picture? We've given a few small examples today of different design decisions that you can make. But really at the top of the list is embedding zero carbon design principles in all aspects of the project. It starts at the very start, as we've said, and it needs to be a clear part of the client brief and something that the whole team follow. I believe, and I think we believe as a company, we all have a moral obligation to do this. It's not about someone else is doing it. Those days have gone. You know, we need to demystify the net zero carbon picture. I think it's a bit daunting when you first think about it. But as we've shown today, if you break it down into smaller chunks and disciplines and design decisions, I'm sure that you can kind of see that each of us has an opportunity to make a difference and do something different. That's not just for engineering like we've talked to you about today. We've got a wide display of people from different areas of industry, vendors, clients, project managers, quantity surveyors, the whole shooting match. So we've all got a role to play. It's not about looking at someone else's job. This is about us doing something differently. We've got a little fun chart on the side there by an author called James Clear from his book Atomic Habits. And it's really just to illustrate that if we do something small every day better, we can go on the trajectory of the exponential curve upwards. If we don't do anything differently, we're going to go down. So if we think we're stood here today doing best practice, doing as good as we can, you're wrong. We're heading down there. And we already, if we stay on that line, we know where we're heading. We're 3 degrees C above the target. So we're in a bad position. So we all need to do something better. And then a final quote in the bottom left there from our friend Einstein. We can't solve problems by using the same kind of thinking we used when we created them. So I think that sums it up quite nicely from our side. We need to make changes quickly. We've all got a role to play. So we have about 8 or 9 minutes, I think, for questions, which is good, if you want to ask questions. So I'll start with the room. Is there anyone in the room wants to put up their hand? Anything you've seen, anything you want to delve deeper into? Yeah.
Hi, my name's Alex. Is this on?
It is, yeah.
Okay, all right.
Yeah,
my name's Alex from Mace. We've noticed the same trend with MEP. That data is just not available for EPDs, and it's we're really struggling with it, basically. I take from your approach that you anticipate that that's not improving anytime soon. That you know, you're building your own database, that you're sort of banking on the MEP systems continuing to not put out EPDs, and is that the case?
Vendors actually now becoming more active and responding to our requests for EPDs. So we believe it's early days, definitely, but some vendors are doing better than others. So we really want to give credit to these vendors. We want to also invite the other vendors to actually start looking into this, really.
Okay, thank you very much.
Yeah.
Thank you. Anyone else in the room? Okay, so we'll throw... Oh, yeah, go on, John. Wait for the mic. Wait. Double mace. Taking over.
So,
We've got Sisk in the back now.
You just mentioned clients.
Yes.
And you know, to my experience, generally when you do a carbon value engineering, you actually bring down costs. Mm-hmm. Narrowing a road is going to make it cheaper.
Yeah. Yeah.
But are clients receptive to changing their mindset and their standard models and their thinking for the last 30 years and making something slightly less resilient? Yeah. And second question, are you having the hard conversations about things that do cost more money at the beginning of a job? Steel, for example. Steel, if you want to get the lowest carbon you can in steel, is going to cost you 10% more than it will otherwise. So how are clients reacting to that message?
I'll take the first one because that was the easy one. I think that's the synergy between reducing carbon and cost. And I think all of the examples that I used, you're right, actually, yeah, they all actually reduce cost as well. So they're the easier conversations to have. And I think clients are receptive to it now, or they're certainly becoming receptive to it. It's making sure that we've got the time to do that process, to work through that process and to get the agreements, because, yeah, then it is happening. And the result is, yeah, it's reduced carbon and cost. In terms of the conversations of the more expensive.
Yeah, I mean, just to pick up on that point as well, I mean, what we look for quite a lot is the no-brainers. It's like, well, it's going to be cheaper and it's going to be lower in embodied carbon. Why wouldn't you do that? You know, just get on with it and do that. So we do quite a lot of work on kind of recommending that to our clients a lot. In terms of the higher cost, we do have the difficult questions. We do raise it with the client and say, look, if you are looking to achieve this lower embodied carbon solution, you know, this element might cost more. And what we try to do is look in the round really and look at the kind of the whole life carbon impact and what target have you set across the board. And there's options you can try, different material you can try here, maybe try that one there. And when you're looking in the round, what's the right solution from a cost and an embodied carbon point of view? So sometimes you might pay more for one and less for another, but in the round you get the overall benefit. So yeah, we do have the difficult conversations.
I maybe just pick up on the client thing as well. I think it can depend on which client and how established they are and the reference design and how ingrained they are into that. So that there is that barrier for those clients to overcome, I think. Hopefully there's a lot of those clients on the call today that are listening to this. And I think the second part, and it's easy for me to stand here and say it and talk about profit and money, because it's not me spending that money. But if we think about it in terms of, is profit more important than the planet, simplistically put, then I'm sure we could all agree, you know, unless you're in charge of the purse strings, but you know, that's a part of it that needs to change as well. You know, there is possibly some money that needs to be spent here to improve the carbon performance. It's not all going to be save, but profits before planet is a question as well, I'd say.
Okay, yeah, if we can just go online. And I know somebody's got their hand raised online. If Eamon, if you could kindly just put your question in the chat, we'll pick it up from there. But yeah, so a couple of recurring themes actually, John. The point that you've made in the room again was made online. It's really about how do we engage with customers to move away from their standard approaches and their standard blueprint designs. And I think you made some really good points on the chat there, Damien. But yeah, there are quite a few customers on the online, so I'm sure they'll look forward to those conversations moving forward. Something a little bit more political, perhaps. There's a question around the use of waste heat recovery, and certainly most customers are making provision for recovering waste heat and bringing it to the boundary of the sites. How can we put more pressure politically on governments to put the district heating networks and infrastructure in place to make best use of that? I don't know, Pete, if that's a question for you.
Thanks. I mean, technically the opportunities are there clearly. We've shown some examples of what we did with air-cooled data centres, which is more difficult to get the waste heat and put it into water and then put it onto grid. So the transition to AI, Oz and I were speaking about this on a call not long ago, the opportunity for AI and liquid cooling and raised temperatures does present these opportunities to more easily convert that and put it onto the grid. Of course, the elephant in the room with this is, where is that network? What's there? It's not there. Some countries are far better set up than others. Politically, I'm not the right person to say how do we put the pressure. I think with the COP28 and the global stocktake and the realisation that we're not doing enough, I think it's for our industry as a whole to lobby and say we want to do this and get together, talk about smart cities. There needs to be more investment and finance. I think we covered that a little bit at the top there. So how can we work out and find the money to actually procure and build these networks, and then we can be a part of that. We are a big energy centre. We're a processing plant. We create heat. Let's make the use of that and let's put it onto the grid. But we've got to get that connection. So that is a challenge for the industry and our sector as well in particular to overcome. But if we look 10, 15 years into the future, supercomputer data centres are going to be gigawatts maybe. At that point there, you've got a lot of heat. You can heat whole cities with gigawatts. So how do we plan for those smart infrastructure and those power plants of the future to make sure that we can capture that heat and not, kick it to atmosphere, essentially?
Yes, some other questions online. A question from Will Booth. Do generators need to cover the whole power load of DCs? If no emergency, if no emergency, they sit there unused for 8,750 hours. But the question really relates to the
do we need gens?
Do we need gens on site? And the amount of...
I mean, it's been on the menu for a long time. Junji covered it briefly on that slide there. I mean, I'm looking around. I don't think I've got Oz, so I don't I'm looking for my client because we can put the facts and figures, and we've certainly done DCs with reduced gens, and I think it's different for different case scenarios for clients. Yeah, co-location market versus enterprise. What can you back up? What do you need to back up? Do I want to put you on the spot, Oz? Yeah, just from your point of view, talk about gens. Yeah.
It's Oscar here from Telehouse Europe. And we own the oldest data center, the first data centers in London, which is our London North data centers. Last 30 years, we never see single power failure. But what we try to do, we work with the Candle, our new design. We try to put the generators in a modular way. And with the HVO, unfortunately, our client is asking generators. Without the generators, they will not come to our site. We get the UPSs, but they will want definitely generators. I think HVO oil is the one solution. Yep. Also, we try to run the generators 50 hours maximum. That at the moment we are looking at it to reduce that much lower, maybe 25 hours in a year. Again, it's sitting there, it's embedded carbon, but we're not using it. That's the reality of it.
No, yeah. Yeah, I mean, the embodied carbon and point, they're noisy, yeah, and they run at night potentially, and that leads to acoustic issues, and, so, it starts to unravel. We've got, maybe this is the last question. We've got 2 or 3 minutes. Make it a good one.
Okay.
An easy one.
I'll do my best. So, yeah, this is a question from Pablo Castano. Thank you. From the point of view of energy efficiency, environmental certification and carbon content, there is a smattering of different calculations being discussed, different approaches by different countries and the like. What are your thoughts about having an industry standard where we're effectively standardising those efforts, especially for electrical balance of plant, like transformers, where efficiency is radically more to do with operational lifetime? I think what Pablo is really asking, isn't it appropriate that the industry or the sector has a standard viewpoint or a standard approach? And I think, just for my contribution to add on to that question, really thinking about some of the metrics that the panel have discussed and presented today, why doesn't the sector have a standard set of targets that we could all be working towards?
It's not there yet. It's one of the goals of the UK Green Building Council and those standards that they're looking to produce, because the industry is calling out for a set playbook to follow. We need to know what good looks like. We talked about some of those things there. Yeah, standardising calculations, being confident in the data you're getting. I was talking to some of the guys about the difficulties of EPD before. We're getting varying results on that, which, you question, what's behind that? Is it accurate? So yeah, we're at the start of it. I think that's why most of us identified embodied carbon is difficult, because PUE and things like that, I've been doing data centers 20 years. We've kind of refined it. Everyone accepts PUE. It's kind of known. It's a calculation there. If you say it's 1.2 annualized, you kind of know where you're at. We don't know with embodied carbon yet. So standardizing those things is very important moving forward. And I think there are moves to do it, and we're certainly working. I'm sure lots of others in the industry are as well. I don't know if the guys want to add anything to that. No,
I think
hopefully that answers the question. Yeah, it's one of the challenges. Yeah,
I think we have time for
we do.
One more question. Question from Ian Miller online. I don't know how the panel might respond to this one. Where do you see the role of stored historic cyber junk in the carbon equation? And I think, really the question there really is for providers, storers, what part can they play in terms of reducing the amount of power usage for?
Yeah, I mean, it's an interesting one. It's storage, so it's data centers with storage. We're not accessing it much. It's probably not a lot of operational processing power, but the facilities are there that are storing all this junk. I'm as guilty probably as anyone in this room. My Gmail account and those sorts of things. Yeah, well, again, like we said, it starts with us. Yeah, so I could, and I should, and I will today, go away, look at my Gmail. I've got emails on there from 10 years ago, probably, I'm sure. So I need to clear that out and stop doing that sort of backup. Do we need to back up our music files? I did that historically. I've got hundreds of CDs. I put them all on some cloud somewhere. I won't mention whose cloud. I don't need them anymore. I've got Spotify and things like that. So I don't really need that backed up on the cloud. And if every one of us in the room, or probably 80% of us, have got music backed up on the cloud, do we need it? No. So I think it's a difficult one. It's an important part. I don't disagree with Ian at all. But starts with us as well. Look at what you're actually doing there. Can you clear up your own junk before you rely on a corporate to do it for you? I'm sure they've got loads of legislation. Right, that's what we wanted to avoid. That is the fire alarm test. So I'll have to say goodbye. Thank you for everyone online for joining us. Have a good day. Thank you to those in the room. And that's a wrap. Thank you so much.